let's look into something called as uniform and non-uniform motion. So one thing is it has to do with motions. So to understand this, to define this, we'll go with an, not experiment actually, we'll go with the statistics. We'll go with the data, and with this data we'll try to define and understand uniform and non-uniform motion. So here I have a data. The data is regarding the motion of two different objects A and B, starting at the same place. Both are starting at the same place, so at the same time, right? So let's map this data and try to figure it out. So we'll begin with 0 indicating 9:30, and we have every 15 minutes we have the data of the object A and B being displaced. Okay, so how far it is away from the origin, we have that data. So every 15 minutes, so we can go with this. This is indicating 10:30, remember. 60 minutes away is 10:30. Then this is 75 and this is 90. So this is time in minutes. This is distance in meters. So maximum is 70. So we'll go with 0, 10, 20, 30, 40, 50, 60, 70. Now, the object initially to begin with was 10 meters away from the origin. And after 15 minutes, it is 20. So 50 minutes, 20. Then after 30 minutes, it was at 30. 45 minutes, it was at 40. That's correct. In an hour, that is 10:30, it was at 50. And yes, 60. And then 70. So if we join all this, what do we get? We'll get a straight line. Now, the next one. Object B is at, to begin with, it's at 12. And after 15 minutes, over here, then 23. 23 will be somewhere over there. 35. This is 30 and 5. 37 at 1 hour, 10:30. It is at 37, somewhere over there. And then 41. 41 is over there. And 90 is 44, somewhere over there. So we have this as our motion. So this is object B, and that's object A. So this is basically our motion of the two objects. Now, what can you tell about object A? The movement of object A is said to be, of course, it will be a guess because we have not yet defined or understood what is uniform motion or non-uniform motion. If you go with your guess, it would be, object A would be, yes, uniform motion. This is uniform. So the word uniform, you guys know, school uniform. What does that mean? Things are same. So what is same over here? Why is that we feel that this is uniform and this is not? This is clearly non-uniform, right? So why is that we feel that this is non-uniform? Because for every 15 minutes, this object has been covering how many? 10 meters. The second object, object B, it's covering different distance for every 15 minutes. And so this becomes non-uniform, that becomes uniform. I hope it made sense. So to define uniform motion, an object covering equal distance in equal interval of time, it is said to be in uniform motion. In a fixed direction, this is something that people miss. So it's one definition. So the direction also has to be fixed. Okay, remember that. And while non-uniform is anything that you undo over here, like say you're traveling and you travel slow, or you're traveling, you change the direction, or you're traveling, you change the direction and increase the speed or decrease the speed. Any one of this possibility, is said to be of non-uniform motion. So let me show you guys with a linear motion being uniform and non-uniform. So let me, so this is an object which, let me see, is moving in a uniform manner. Right, you can clearly see it is covering equal distance in equal interval of time. Let me copy this. This is an example of uniform motion. It's covering equal distance in equal interval of time. If you take a scale and measure this, all of them will be, say, this looks to be around, if I take a scale and put it, it depends on the screen size, right? For me, it is around, I'm guessing 3 centimeter. So all these are of 3 centimeter length, long. If you look at a graph, the same motions graph, the program generates in that manner. It will show you, it will let you control the movement of an object in a linear fashion. And it will end of it, whatever movement we saw, that result is being displayed. So here we are just looking at distance and displacement versus time graph. This two we are ignoring. So you can clearly see there is consistent increase in distance with respect to time. So this is your uniform motion. And displacement is also the same, because we're not changing direction. Things are moving in a straight way and with a constant speed. Right, now let's move on to non-uniform motion. So let's have a look at this now. No, I can't actually. No, I can. So can you see that? It's increasing, decreasing the speed, and some stretch I'll keep it same. Here again I'm increasing. So you can see this is set to be non-uniform. So I'm not changing direction. I have not coded to change direction. We can code, it's not a big deal, but anyways, the entire chapter is to do with linear motion. We just go forward, if not backward. There's no other motion that we are looking at. So you can clearly see it is non-uniform. And the graph also tells the same. Okay, this is not popping up. Oh, I didn't. Okay, sorry. Yeah. I made a mistake. Just a second, let me correct this. So let's redo this again. Going fast, then I'll slow it down a bit. Then again, I'll make it go faster. Then at the same speed. And now I'll stop this. So this is an example of non-uniform motion clearly. Let's look at the graph. So you can clearly see the graph is all weird. It's not a straight line. This is an example of non-uniform motion. So it's traveling weird distance in equal interval of time. Okay. So as a definition, an object covering, non-uniform is a body or an object covering unequal distance in equal interval of time, or if its direction or magnitude or both changes with time, with a fixed time, then the object is said to be non-uniform, or non-uniform motion is said to be in non-uniform motion. Okay, so write the heading, write this particular graph and fill in this blanks, and then you have to define this two and give an example.